Hey everyone, this is Dr. Walker. This is a video going over the examples from v009C on graphical interpretation of acceleration. Let's look at the first example. We are given a position time graph here, and we're told that the position of the object varies according to this graph. We want to graph a velocity time graph and an acceleration time graph. So I've left two blanks for both of these graphs here. So the purpose of this example is to make us understand the relationship between the graphical relationships between position, velocity, and acceleration. All right, so notice that there's not going to be any numbers here. This is just going to be a qualitative example. So let's look at what happens to the position from 0 to point A here. So what we have here is that the slope is increasing, right? It's not a straight line. We have a not so steep slope and then it gets steeper. So that means the velocity is increasing. We do not have a constant velocity. We have an increasing velocity. So we start with 0 velocity and then we increase to some other velocity here. Now let's look at what happens from A to B. From A to B, we do have a straight line. If you can't see it, just look carefully. This is a straight line here. Remember, when you have a straight line on a position time graph, that means constant velocity. So it's still a positive velocity because we're moving from a lower position to a higher position, so it's a positive velocity to the right, but it's constant. So we're going to put a horizontal line showing that the velocity is not changing, but we still have some velocity because we're still moving. And then what's happening here, from B to C and then to D, what we see here is that the position is still increasing, but it's increasing at a slower pace, right? You can see that the slope is steep here, and then it gets less and less steep. That means it's taking more and more time to cover a certain distance. So we're actually slowing down. Now, it might be hard to tell if we're slowing down at the same rate here that we are here, but it turns out that we are. So we are just going to be slowing down until we stop. Can you find a point at which we stop? That means that the slope of the line tangent to that point has to be 0, right? When you're stopped on an x versus t graph, right? That means that the slope is 0 because the slope is the velocity. If you're stopped, that means your velocity is equal to 0. So the slope of the line tangent to point D here, this is a horizontal line. That slope is 0. That means we're stopped at this point. So that means that our line here from point B to point D, we're going to slow down until we reach point D. Now, if you didn't know if we were slowing down at a constant rate, that's okay. You could have had a different slope here if you wanted to, but I'm just going to assume that we were slowing down at a constant rate. All right, let's figure out what happens now from D to E. Is our velocity positive or negative? Well, up to point D, we were going from a lower point to a higher point, so we had a positive velocity. But now we're going from a high point to a lower point. Now we have a negative velocity. So we're going to have to draw our line down here. Now, what is going to be the slope of that line? Well, we are going moving with some slow velocity, and the line is getting steeper and steeper. Remember what a line looks like when you have a negative velocity and you're speeding up because it's getting steeper? That means that we're just going to continue the straight line. Again, it could have a slightly different slope. It's kind of hard to tell, but I'm going to assume that the rate of change of the velocity is constant. But this is the line from D to E. It shows a negative velocity because we're below the origin here. And it has a negative slope, which means negative acceleration, combined with a negative velocity means that you're speeding up. So this one here means slowing down, but this line here means speeding up. All right, and then what happens here from E to F? The line is steep, and then it gets less steep. That means we're slowing down from E to F. So if we're slowing down, that means that our slope is now going to have to be positive. So this means slowing down, because we have a positive slope here. That means a positive acceleration, but we have a negative velocity. Positive A, negative V means slowing down because V and A are in opposite directions. And then finally, from F until the end here, the slope of the line tangent to any point is going to be horizontal, which is 0. That means the velocity is 0. So the graph is going to look like this. So doing these graphs definitely takes a little bit of practice, and we will have some homework examples so that you can practice these. The hardest thing is remembering that a negative acceleration, right, doesn't always mean slowing down. It depends if you have a positive velocity or a negative velocity. All right, let's look at now what the acceleration versus t graph is going to look like. So we know that the slope of a line tangent to any point on a v versus t graph is going to give us the acceleration. So let's analyze these straight lines here. For the first segment, the slope of this line is positive. That means we have a positive acceleration. Now this is a straight line, so that means that we have a constant acceleration. And once again, when we went from this graph to this graph, we couldn't tell 100% that it was a constant acceleration. It could have been a non-constant acceleration. Maybe the velocity could have looked like this, something like that. And then the acceleration graph would be a line that has a positive slope. But we assumed constant acceleration. What about for the next segment? The slope of a line tangent to this point is 0. That means 0 acceleration. So we actually jump down to 0 here. And that's okay to jump down. And then from B all the way to D and even to E, we have a negative slope. Negative slope always means negative acceleration, right? Doesn't always mean slowing down, but it always means negative acceleration. So from B all the way up to E, we have a negative acceleration, so we're going to be below 0. So we're jumping down. And then from E to F, the slope is positive. That means a positive acceleration. So we are going to jump up. Now, according to this picture, this slope seems more steep than this one. So I'm just going to say it's a slightly higher acceleration, but it's hard to tell. And I'm just going to draw it up to point F here. So we're going to jump all the way up here. And then for the last segment, our acceleration is 0 since the slope is 0. So we're going to jump down to 0. So hopefully these graphs make sense, and we will have more practice in the homework.